जो ब्रह्मांड को जुड़े
अच्छा, पर वो है क्या?
सांस महसूस करो
कुछ महसूस हुआ?
महसूस हुआ
हाँ महसूस हुआ।
बड़ी देवी शक्ति है
सच?
लगता है तुम्हें भी ज्यादा महसूस
मैंने
طب ده Hello everyone. Here to extend Department of Physics, Government Model Science College, Rewa. For 2 days international webinar on solar activity, effects on Earth environment. Tiwari, for 2 days international webinar. Welcome to all our today's session. Kumar Srivastava sir, professor, physicist, and additional director, Higher Education Department, Rewa and Sahdol Division, Madhya Pradesh, as a chairman. Our eminent speakers are Dr. Thomas Morzek, scientist, Space Research Center, Poland; Dr. Arun Kumar Avasthi, scientist, Space Research Center, Poland; and Professor Rajmal Jain sir, retired senior scientist, PRL Ahmedabad. Our principal, Professor Aarti Saxena ma'am, dignitaries and participants who are connected with us via Google Meet all around the world. Now, for a short introduction, I would like to invite Dr. Yash Kumar Singh, Head of Department and Convener of this. Dr. Yash sir.
Thank you, Mr. Today, the 2 days international e-webinar is being organized by solar activity effects women. Before we proceed, let's welcome our chief guest, Honorable Professor Pankaj Srivastava sir, the additional director of RIVA. Principal, respectable. Please welcome both of them. Let's speaker who will to that how the solar activity are affecting our earth and environment. The Physical Research Laboratory, Ahmedabad, Gujarat, in Professor Dr. Thomas Academy of Science. Poland, and Dr. Arun Avasthi. He is also the scientist in space research, another in sure if this webinar will our researchers in cosmic rays field and the MSc students to know and to learn about it parapractically. Thanks all my friends. Thank you.
Thank you so much, sir, for your short and sweet introduction. Now I would like to invite Professor Pankaj Srivastava, sir, for inaugural speech.
Principal, Government Model Science College, Rewa, Dr. Yash Kumar, convener of the conference, and
staff of the Physics Department, Government Model Science College, Riva, eminent speakers and participants. It is a great moment of Physics Department of Model Science College, Riva, to organize a national, international seminar, webinar on the topic of the solar activity effects on Earth environment. As the various solar outputs effects on our Earth system and interplanetary medium. These solar outputs are solar flares, solar wind, coronal mass ejection, and these prevail in interplanetary medium and produce the interplanetary magnetic field. And these solar outputs produce effects on the Earth's magnetic field. Activities are directly associated with the cosmic ray intensity. We generally use the cosmic ray as a tool to study our environment and solar activity. Cosmic ray intensity on Earth surface around the interplanetary space shows in various means the solar activity. When the sun produces the large solar activity, it affects largely on Earth's magnetic field. It produces disturbance in Earth's magnetic field and decreases in cosmic ray intensity. In this moment, all the participants of the conference will be benefited as solar activity in Earth's geometric field and various imminent provide the various okay.
Thank you so much, sir, for your words. All participants are requested, please mute your voice and video so that we have uninterrupted session. All participants are requested, please mute. Nisha Chauhan, ma'am, please. Sarita Tripathi, please. I request all participants and mute your audio so that we have uninterrupted session. Sarita Tripathi, otherwise we will remove you. Ashish Gupta, sir, please off your video. Thank you so much, sir. Now our first speaker is Dr. Arun Kumar Avasthi from Space Research Center, Poland. Before calling him, I want to give a short introduction about him. Dr. Arun Avasthi has completed his PhD thesis on solar flares from Physical Research Laboratory, a unit of ISRO, We all know that about ISRO. He then moved to Poland to carry forward his postdoc activities before moving to China. After receiving the prestigious Marie Curie grant, he moved to Space Research Center, Poland, to work on X-ray emissions from the sun. He has published more than 30 papers in the international journals and is worked on 3 sponsored projects as principal investigator. His talk will introduce the effect of solar activity on the Earth's environment. Now I would like to call Dr. Arun Avasthi. Sir, please go ahead.
Hello, I hope you all can hear me.
Yes, sir.
Okay, great. I will try to share my presentation. Sorry, I was a bit late in office. I was expecting to join. Oh, but it's almost about time. So I will open my presentation. Please bear with me. Okay, and just a moment. I'll try to share. Just wanted to check. Can you see? Thank you.
Yes, sir.
Okay, great. So, everybody, it is my pleasure to Earth. So, as I was just presents a center of Polish Academy. Astrophysics, cosmology, solar physics, and developing instruments. So I am in space at this point of time, and are also involved be in this team. And today version of Professor Rajmal Jain, where the topic or the prime focus of my PhD was to study the processes which initiate solar flares. World around solar flares, the effect on sun and its effect, only slightly its effect on Earth. So what I am going to introduce today in this talk will be about the activities on the sun and the medium through which the particles and emissions that are expelled by sun are reaching to Earth. Try to convince you, of course, probably if you have already been introduced, which I believe, with the solar activities and its effect on Earth, you are already convinced that we have a lot of observational significance. So here I'm showing you
Sorry, sorry to interruption, sir. Your slide is not visible.
Is it?
Only your screen is visible.
Uh, okay, so maybe I can. Okay, maybe
Yes, sir.
it will be. Yeah. I made my presentation in full screen. Is visible in full screen?
Yes, sir. It is
Okay,
visible.
perfect. Thank you very much. So that's good that you have not seen my first slide. Have of I mean energy and life on Earth that we are sure of. The perfect distance is giving us enough of develop based on what we can actually adjust to in terms of temperature, in terms of let's say oxygen, the atmosphere in that sense. So this is the of God. Okay, let's start with that. I mean, so it's not just the happy face. There are also activities on sun other than the gravity which is holding, and we are seeing this nice life on Earth. There are some miracles on Earth as well, which are trying to help us, which are trying to save us from the activities that are occurring on the sun. So after this nice, I mean, presentation of sun and earth relation, I would like to take you close to some observations. So just to introduce you, sun has, apart from what, aside from what we see usually the sun as a rounded, so smooth disk, yellow disk in the sky, sun has spots. Spots are actually just like the moles on our face. So these spots are actually the locations where there is a strong magnetic field which kind of expels the plasma away. And that is why, the sun, as we see here, is the sphere of hot plasma, and the surface is close to 5,800 Kelvin. But there are some places on the disk of sun where the magnetic field is more concentrated than at the other location. So for example, here I'm showing you some of the location where you can see such moles, and this is an excerpt from a paper which suggests, and I have experienced this myself, that of course it is not good to look the sun in its daytime, but when the sun is rising or setting and is very close to the horizon, if you get a chance to look at it, if the spots are bigger, sometimes you can even make you can even find the spots, you can see the spots from your naked eyes from Earth. But in order to know more about it, of course we have to rely on the observations from bigger eyes, from the telescope which has bigger lenses. So in the left side, I'm showing you such excerpts which gives you a feeling that the sun is not that smooth and it has spots. Now we know are the areas where we have more concentrated magnetic field. But okay, if we see just the left image, we kind of see that okay, the sun appears to be a sphere and there is nothing surrounding. But if you see when unraveling the secrets of nature, So there are times when we have immersed by these magnetic field lines. And here is a artistic rendition of such a magnetic field on the sun. So just like this image, I have you to solve the equations. We have to imagine that there is a north and south polarity, and just like a magnet. So there is a, just like on the earth, we have the material in the is rotating, and that's why we have this magnetic naked, and the plasma is not sufficient enough to contain these magnetic field lines, so they extend outward and way outward. It's like a magnet, a very big magnet. Those spots, the magnetic field in the locations where the magnetic field concentrations are higher, the strength of magnetic field is close to 2 to 3 Tesla. And so this is into 10 raised to the power of minus 9 Tesla. This very small spots have. This is natural curiosity of and to Earth. We need to know more. To give you an idea of free lines, I am showing you here the real observations from two different instruments. So I have already shown you this picture, but just after this, the picture shown here is taken from space from an observatory named SOHO, and this gives you some idea of how extended these lines are. So let's say I give you an idea and I try to make some analogy here. So this is close to solar diameter, this bracket, and the radius of sun is close to 700,000 kilometers, so 700,000 kilometer by 2. Okay, now I just copy pasted this bracket along the whole this image. So this is close to 24 solar radii, so 24 times 700,000. So we are not very far from such magnetic field lines, just to give you an idea how close these magnetic field lines are. And so these are the real observations of plasma embedded in field lines, which only magnetic field lines have strength of. So this gives us an idea that the sun produces strong magnetic field lines which are extending way outward from the real observations. Okay, now I would before going outward, let me take you to how these magnetic field lines are generated and what we know about the solar interior. Because okay, we have some observatories, we have advances in the instruments, so now we can see much beyond the solar corona, that is the outermost atmosphere of the sun. But let's find out what is very close to the sun as well. So here I am zooming in. So this video zooms in a this is the typical sunspot. Then let's zoom in a bit, and these are all observations from the telescope on ground. So when we go very close to the solar surface, you now start to realize that the surface is not that smooth, and we start to see some patchy structures, the structures that we see on ground when it is not given water for a long. Solar lingo, this is called granulation. So these granules and the bigger ones are called super granules. So these are kind of the structure that are produced the energy due to nuclear, and this energy is transferred to the outer cell, and at some point of time from 0.7 solar radii, it starts 0.7, so 70%, after 70% of traveling from the center to the sun's interior, it is so give you an analogy. White water. So this is so our hot plate is the core of the sun, or even to the best analogy, this can be actually very close to the what we call convection zone, which is 0.7 to 1 solar radii, and the heat kind of gives some kind of bubbling in this water, and the same bubbles are here. So see how close we are in terms of relating the processes on the sun. Of course, the mathematics of this is very complicated, which I do not want you to bore with. But please believe that this is a similar process that we see when we make tea. And this is called granulation. So just to give you an idea that the solar surface is not that smooth as we see from the visible observations. And then here I'm showing you an animation which is made from real observations of the sun over a duration of few days. So to start with, as you can see, that there it appears that the sun has certain rotation. And how do we know it? Because sun has spots, and when we have observations for a few days, we see that the same spots which were at one point, they move to from solar east to solar west. So that is how it was found out that the sun is rotating. And then going much deeper, when we kind of okay, so it was due to find out what sun is made of and what are the processes inside of the sun. So in order to do that, it is very difficult. It is almost impossible to directly observe the solar interior because of a term called optical opacity. So the plasma is not allowing the photons directly from the to see the solar interior. But it's like the human body. So in order to check our heart rate or heartbeat, we do not have to put a device inside, right? We just put a stethoscope. So the similar stethoscope is kind of put in the solar atmosphere from the observational point of view. And this stethoscope actually feels the bubbling, the oscillations in the solar on the solar surface, and through that we predict what can be inside in the solar interior. And here is this animation which shows that there are regions of rotating plasma in certain region, which is in terms of activity, this is called solar dynamo. So this is dynamics of plasma in the solar interior. And then this dynamics is actually the parent dynamics, which produces a strong magnetic field lines at some point, which are kind of appearing in terms of sunspots. So we see that we have the magnetic field lines which are along this this plasma, which is rotating all along through the sun. But at some locations, the magnetic field lines are more concentrated, or the flux of magnetic field lines are more than the other places. So at those locations, we see such spots. Okay, so this is a bit about the solar interior. Then I would now like to come back to the atmosphere of the sun. And actually, when we have a spectrograph like the prism that we have in our experimental lab, and then we try to project the spectrum of the solar light, we see some emission lines. So this is a typical spectrum from the sun's emission. So in addition to, so these are actually the lines. So this, the x-axis is wavelength, and the y-axis we have a slit along at some position on the sun. So we, at some locations, we also see these absorption line. For example, here. So absorption, because you see these are the line which are, these are the locations which are bright in the spectrum. But at the same time, we also see these are the lines which are, I mean, they have a negative brightness. They are in absorption. So these absorption line actually are the indications of what kind of atoms, molecules, ions from which the sun is made of. Because you see, we have to probe everything which is at least that we can observe in order to model, in order to predict what we are seeing from the sun. So these absorption lines kind of tell us about what sun is made of. So for example, this absorption line in H alpha, it is coming basically close to more than 500 to 1000 kilometer above the solar surface in the what is called the second layer of solar atmosphere, known as solar chromosphere. So we have the top, the layer which is visible is called photosphere. The atmospheric layer which is above the photosphere atmosphere is called solar chromosphere. And chromosphere because we have such nice chrome means colors, so we have such nice absorption lines in the solar atmosphere of that layer, starting from 500 kilometers and above. So that is why this name appeared. And you see, this also kind of provides us an idea of what are the elements. And do you know what actually kind of creates such absorption lines? We read that the, let's say, if an electron has certain energy which is in the outer shell of an atom, and this energy is given to it, it will kind of eject that electron, and electron will or if the electron on the other way absorbs that energy. So we see that in the absorption line, for example, that we see here and in the sodium. I remember that in my master's, I also did certain experiment where we did experiments on absorption line, and we also did this for sodium. So we have this, what we call double line at this location. So for that, we had that sodium lamp. So we have a light source, the sodium lamp, and then when we took this spectra, we found that from the light source, this lights from the sodium doublet have been absorbed. So this through this way, we kind of get the idea of what is solar atmosphere made of. And then finally, one more detection technique which I want to introduce here before going to the observations is the remote detection of magnetic field. So by sitting on Earth, taking observations, we can actually identify the magnetic field at different locations on the sun. So there is, we read about it in our atomic physics classes, that there are specific land effectors. They correspond to certain lines at certain wavelengths. And this land effector is effective for different magnetic field. So what I mean to say is, some absorption lines, they have such a splitting which is different for different strength of magnetic field lines. So here I am showing you the same absorption line at 5250 angstrom. And let's say if the magnetic field is 200 angstrom, the observations of what we call Stokes I parameter will be like this. And when we have strong magnetic field, there will be a splitting like this, a doublet like this. So through this splitting, so when we introduce this, observe this splitting, and we know the actual wavelength, so the Zeeman splitting relationship allows us, and we already know the land effector for such lines. So through this relationship, we kind of identify the magnetic field at that particular location by such observations. So these are the ways through which we have the real observations of conditions. Let's say the plasma and the temperature of the plasma and the magnetic field in which this in this environment, and also sometimes the density of the plasma. Of course, we have also to use some theoretical models for that, but we can predict we can interpret the temperature, density, magnetic field, and many more properties, starting from the solar photosphere to the corona and beyond. So moving on. So now I get very close to where I started my PhD thesis. So this is about the solar flares. So one day on September 1, 1859, Richard Carrington, who always took the observations of the sun through a small telescope, and he projected this onto a plane surface, and was kind of drawing the structure of the sunspots. So now, since we have these recording tools, for example, we have these digital cameras, we have the chip on which we can record. But in the past, for recording any activity, the astronomers or the enthusiasts have to do a lot of work. They have to be very creative. They have to be actually be the artist. So Richard Carrington was saving such observations for every day by making such drawings, which I'm showing you here. So these caterpillar-like structures that you see here are actually the drawings of sunspot that was made in around that time. But on September 1st, he also saw some bright emission, some area which was bright in contrast to the dark sunspot. So this brightness, after his identification, were understood to be little bombs, explosions in the atmosphere of the sun, close to the location where the sunspots are, and these were named as solar flares. Now we have very good observation, so it will be incomplete if I do not show you a movie of such observations, just to give you an idea of how violent these activities are. So here is a movie of such an activity where we see our sun in wavelength 304 angstrom, which is observed by a space-based observatory named Solar Dynamic Observatory. So in this wavelength, here we are looking at some chromospheric altitude, I would say, to not to be very much wrong. And here we can see that apart from this solar atmosphere, which itself looks like how we call this Jwalamukhi, we have certain activity which looks like something has triggered from here, which expelled the material which was in its surrounding outside. And this activity is the one that have been observed on simple drawing by Richard Carrington back in 1859. So the research, the understanding of solar flares is old, but not as old as the understanding about sunspots, star spots, but more than 150 years for sure. So to give you an idea of how violent the energy release is during this tiny bump termed as solar flare on the sun, is that one solar flare's energy equals millions of 100 megaton hydrogen bombs and 10 million times than exploding volcano. So just to give you an idea of how this so these kind of activities are very close to concentrated on the sunspots here. So these activities are understood to be originated by the interplay of magnetic field and plasma that is in here surrounding, named as magnetic reconnection. And I will not go more into the detail of solar flares because my host and my colleague, which is scheduled next after my presentation, will give a very nice overview of X-ray, which is the invisible view of the sun and the flares in his talk. So just to give you an idea about the strength of the emission here, but this is not very strong, I would say, because it's just 10% of the energy the sun emits per second. So it's not very, from the sun's perspective, it's not much. But from the Earth's perspective, we have to take care of this. At least we have to know. We cannot do anything about what is happening there, but we should be prepared. We should know what is going on there. And now from this advancement, we have very nice, very good observations. So we should be more prepared. If I quote what Neil deGrasse Tyson is kind of presenting solar flare as, we should be more prepared. It's not like sun is more active now. It's just that we have very, very good observations. So every now and then we hear about it in the newspapers in terms of very popular articles, which is very good because these activities needs to be shared to common person. And now, since we have good observations, we should predict what these solar flares have for us, because they, as I will show you in the following slides, they expel particles, charged particles, which reach all the way to Earth and beyond. But before going to this direction, let me also show a bit about what is saving us from what sun expels. So this is our Mother Earth, and it has a magnetic field cocoon. So this magnetic field is due to, as we know, is from the planet's liquid iron core. And since we have such a core in our such a iron core in the center of our Earth, this provides us the magnetic field. And you see the miracle of nature. This magnetic field is just sufficient enough. This magnetic field was not sufficient for Mars, on Mars, but here it's just sufficient enough to save us from what is coming from the sun. So this is how now we know that the sun has magnetic field. Its magnetic field extends way much beyond, and our Earth also has a magnetic field. So naturally, let's go to the Sun-Earth connection, which is the title of my presentation. So here is the sun, which has, as I have shown, expelling the particles embedded in the magnetic field lines, which are generated in the sun, but now they are expelled and they are coming towards Earth. So this is a schematic diagram, and you see the effect of this such a is that we expect magnetic field to be symmetric. Of course, we see that we have some kind of compression. And this is another example of how affects our. But this is, as I told you, this is sun where you can see these are some 10, and the brightness actually represents a kind of magnetic which is generated in the sun, and in terms of solar physics, flux rope. So magnetic flux, but it is bundled in the form of rope. So these are called flux ropes, and these flux ropes are magnetic field bundles, but they also contain plasma, and thanks to that we image them in different ways. 1990s stream of particles from the sun, which is called solar wind. So we have to be knowledgeable enough about all of these both of these kind of streams, just to make sure that our satellites and everything that is and okay. So here I'm now NASA. It is available online as well, and this shows you how the plasma expelled from the sun travels from the sun to the Earth and beyond, and of course added with this is animation for we see that the expelled plasma, this is Earth's magnetic field, and okay, I just like to hold this emission here. So when this plasma reaches Earth, as you can see, this compresses, but still towards us, but we not completely saved, because now you see, so the magnetic field is strong enough but not completely strong. So but most of the charged particles are deflected to the backside, but in the backside so the opposite magnetic field lines, they actually reconnect and provide some window to these charged particles from the backside, and they come so these magnetic fields are mostly, if we say, are connected to the poles, and on the poles of the Earth, they produce this nice colored lighting, which is termed as aurora. So you might have seen the photos of auroras in your desktop background most of the time, because they are indeed very beautiful, and they are the very close signatures of our relation, this and this is violent relation of sun to the Earth, but still in that sense it is not not too violent, because this is not affecting our daily life, and this is most of the time when they are not very strong, this is concentrated only up to the poles. So this is only nice observation. Then let's go to now the real observation. So here is the real observation of, so in the middle this is sun. So this already is 700,000 kilometer multiplied by 2. So now you can imagine how far how far is the extent of this animation, this image. And we see the expelled plasma from the sun is traveling all around. And this is the one that we have. Oh yeah, so I would like to also mention here that we have some space observatories which are providing such observations. And if you can notice, in the beginning there is some expelling of plasma and magnetic field from the sun, but later on we have some effect on the detector. So these are real effect of impinging of charged particle on the detector of the instrument. So these charged particles are really, they can be harmful, and they have proven to be harmful, you see. So, and now we again come back to models, because we cannot observe the entire solar system. So we have to start again such a modeling where we have sun, Mercury, Venus, Earth. And there is one more there are in fact twin observatories called Stereo A and B, which observe the sun from multiple directions. And as now in this animation we can see that we have of course we have certain oh yes, so wow. And this is the best part of adding the observation from the sun's corona to here is our Earth. So we have some, so that yeah, so we have some material which expelled from the sun, and now it is reaching to the to Earth as well. Plasma close to Earth along this point, and density of particles that are in the location of the this meter here, which is in the green zone, and as